So here, it has been told we have to find the general solution of this differential equation, which is 1 plus tan y times dx minus dy plus 2x times dy, that is equals to 0. So if we rearrange it, suppose if we divide both sides by dy, then we will get 1 plus tan y times dx by dy minus 1 plus 2x, that is equals to 0. Um, then we can write it as 1 plus tan y into dx by dy minus, this will be obviously this 1 minus of 1 plus tan y plus 2x, that is equals to 0. Then if we divide both sides by 1 plus tan y, then we will get dx by dy minus 1 plus 2x by 1 plus tan y, that is equals to 0. So this we can also write it as dx by dy plus 2 by 1 plus tan y into x, that is equals to 1. So it means this is a linear differential equation which is of the form dx by dy plus px, that is equals to q, where p and q are functions of y. So therefore, the integrating factor in this case, that will be also e power integral p dy. And the general solution will be given as y times the integrating factor, that would be equal to integral q times integrating factor into dx. So now, so here the function p, that is 2 by 1 plus tan y, and the function q is nothing but 1. Therefore, we have to find the integrating factor, which is equals to e power integral p dy. Okay, so this will be so we have to first convert this tan y into sine and cos. So we can write it as e raised to integral. So let's say we write this as, suppose, e power. Let's say this integral, we take it as I1. Okay, so e power I1. So let us find out. So let us find this I1. So this I1 will be equal to integral 2 dy by 1 plus tan y. So this I can write it as sine y by cos y. Now if we take the LCM, then this cos y will go up. This will be 2 cos y dy divided by sine y plus cos y. Okay. So then therefore this I1 can be written as integral, this will be sine y plus cos y, then plus we can do cos y minus sine y by sine y plus cos y into dy. Okay, so therefore this I1 also can be written as integral dy plus integral cos y minus sine y divided by sine y plus cos y into dy. Yes or no? So the integral of dy, that will be y, and plus, see here, if we take suppose if you take sine y plus cos y, that is equals to t, suppose, then if we differentiate both sides, then we will get cos y minus sine y, that will be equal to dt. Yes or no? So it means that this will be integral, so this will be dt by t. So this we will get y plus log base e mod t. So t is mod of sine x plus cos, sorry, sine y plus cos y. So this will be the integral I1. So therefore E will be, so therefore, sorry, the integrating factor we have to find. Therefore, this integrating factor, that will be e power I1, which is e power y plus log base e mod sin x plus cos x. Sorry, sin y plus cos y. So therefore, this can be written as e power y into, this will be sin y plus cos y. This is the integrating factor. So now we also need to find integral q. Q is 1 into integrating factor e power y into sin y plus cos y into dy. Here I think we did something wrong. Yeah, so this will be dy actually, sorry. Q if dy. Since y q and p are both functions of y, so we should, and here we should not write y, this will be x, sorry, x times, I should change it. There is something wrong here. The general solution in this case will be x times the integrating factor, that is equals to q integral q times integrating factor into dy. Okay, so now this, how to integrate this function. So now this is integral e power y into sin y plus cos y into dy. So now this we can write it as integral e power y sin y plus integral e power y cos y dy. So now if we, this will be dy, sorry. And so here, if we take this as the second function, this sin y as the first function, then we will get sin y into e power y minus integral, so this will be e power y dy, then integral d by dy of sin y into integral e power y dy whole integral dy. Then plus this, I can keep it as it is. It is e power y into cos y dy. So this will be e power y times sin y minus this will be e power y cos y. So this is minus integral e power y cos y dy, and this is plus integral e power y cos y dy. So these two will cancel out, and then we will get e power y sin y plus c. So therefore, the required here, I think the general, yeah. So therefore, the required general solution of the given differential equation is x times the integrating factor, which is e power y into sin y plus cos y. That is equals to this, which is e power y into sin y plus c. So this can be also written as x into sin y plus cos y. That is equals to sin y plus c times e power minus y. So this is the final answer. Thank you.